Alright, my next example is kind of innocent at the first glance, but it is in fact harder than all the previous ones. Alright, so again, we have our separable differential equation. So the first step is to separate the variables. So we move everything with y to the left-hand side and everything with t to the right-hand side. So we're going to get dy over y on the left equals 2 dt on the right. So the next step is to introduce integration. Right, and then we do the integration. So the antiderivative of 1 over y is logarithm of absolute value of y. And the antiderivative of 2 is, of course, 2t. And we should write plus constant. But notice at the same time that when we divide by y, then we assume that y is not 0. But in the original equation, y may be 0. If you look at the original equation, then if you let y be 0, then you will get 0 prime, the left-hand side, equals 2 times 0, which is a true equality. So which means that y equals 0 is a solution of the original equation. So actually, or y may be 0. Alright, so let us look at the complicated part first. Right? So let us continue with this. Logarithm of absolute value of y. So let's apply the exponential function to this whole inequality. So we raise e to this power, so then we get absolute value of y equal e to the power 2t plus constant. And then this is of course the same as e to the power 2t times e to the power constant. That's the absolute value of y. But y itself is going to be this thing plus minus, because this is the absolute value of y, it is always positive, but y itself may be positive or negative. So I will write plus minus e to some power c times e to the power 2t. Well, but what is this e to the c? So let me rewrite it maybe with a different color. So notice that c is any constant, right? So c is any real number. But if c is any real number, then e to the c is an arbitrary positive number. But if e to the c is an arbitrary positive number, then plus minus e to the c is an arbitrary non-zero number. But at the same time, let's not forget that we have this or y equals 0, and of course if we multiply 0 by anything we still get 0, so we can just, instead of just writing just 0, we can write 0 times e to the 2t. Right, and now we need to make an effort to understand this. So now we have just shown that every solution of this differential equation can be written in the following form. So it is either e to the power 2t times a non-zero constant, or e to the power 2t times 0. But if it is either this or that, then either way we get that e to the power 2t times some constant, which is either non-zero or 0, but if it is either non-zero or 0, then it's just any constant. So which means that in the end of the day, we can write just any constant times e to the 2t. t. Well, however, maybe it is not very comfortable to denote this new constant, which we came up with in the end by the same letter c. So let me rename the previous constant c to d. So now this is going to be d, and this is going to be d, and this is d, and this is also 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 d. Well, it's not necessary to do it, but if you're uncomfortable with denoting two different things by the same letter, then it's better to do it. Right? So let me just again mention that. So let me use a different color. So just as a comment that this constant c is either plus minus e to the d or 0. And the logic is that if d is an arbitrary real number, then e to the d is an arbitrary positive real number. So plus minus positive real number or 0 will give us an arbitrary real number again.